All right, so sometimes when you do rational equations, you end up getting quadratic equations. So just a little review of how to solve quadratic equations. We did this, I guess this was just last unit. Seems like such a long time ago. But there's different ways you can solve quadratics. And we'll kind of talk about that here. So if you have just like a simple quadratic where you just have like a squared term and then a constant, you can just solve directly for the variable. You can just kind of get x by itself. So I'm going to divide by 3, and so we get x squared equals 31, and then you take the square root of both sides, and so you get x equals positive or negative square root of 31. Remember, we do exact answers in here, so you leave it as the square root of 31. It's possible we'll run into some you have to reduce. That might happen. We had to do that last unit. Square root of 31 is not going to reduce. There's no perfect square that can go into 31. Don't forget also about the positive or negative. Okay, there's two numbers that if you multiply, you get 31. Multiply by themselves, you get 31. Positive square root of 31 and negative square root of 31. Okay, so that's that. One can use this method when there is no linear term, or that's the technical name for it. It's just kind of the x term that doesn't. There's no x term that doesn't have an exponent showing, right? This is like, remember we call this this is the quadratic term. This is linear, and then this is a constant. Okay, so where you're lacking the linear term, you can do that. You can solve for the variable directly. Okay, next one, we do have a linear term, so we're going to have to use a different method. Let's do it by factoring. We could have gone a different route too, but let's do it by factoring. So we have to think of two numbers, and you can do this kind of thing. Two numbers that multiply to negative 54, add to 3. I think that'd be positive 9 and negative 6. Okay. And so this becomes, you can rewrite this as x plus 9 times x minus 6. And then you have to think about, well, what would make this true? What values of x would make this true, right? So we have two things being multiplied. And if you have two things being multiplied and that equals 0, well, one of those two things has to be 0. Either x plus 9 equals 0, or x minus 6 equals 0. And then you can solve these two little mini equations. You could also do this in your head. You notice it's just going to be the opposites of these, right? So negative 9 plus 9 gives you 0 here. That would zero out the whole thing. So that's one possible answer. And then positive 6 would make this become 0. 6 minus 6 is 0. So that's the other possible answer. So here are your two answers. I guess I should have put the official way to write that would be like this. Okay. When can you use this method? Well, it's kind of a funny answer. When the quadratic is factorable. You can factor it. You can solve by factoring when it's factorable. What a great answer. Huh? No, I mean, what that means, you guys, is every single quadratic is not factorable. I mean, if this was like 53, if it was minus 53 instead of minus 54, it wouldn't have been factorable. If you don't want to deal with this at all, you're like, I don't want to have to figure out if it's factorable or not. I don't have to go through that labor. It's fine by me. Use the quadratic formula. The quadratic formula, in fact, let's answer this question first. When can you use this method? You can use it for any quadratic. Okay, so this kind of works anytime. So if you'd rather just be like, yeah, I just want one way to do it, fine, use the quadratic formula. You could have even used the quadratic formula here. You'd have to do a little rearranging there, but there's a way to do it. Okay, so the quadratic formula, if you recall, and hopefully you can squeeze this on. I know you guys may not have this room over here, but try to put it somewhere on your note page, or maybe you just have this thing memorized by now. I don't know. So negative b plus or minus square root b squared minus 4ac all over 2a. X equals that is. Okay, so we Yeah, this works for any quadratic. Okay, A is 2, B is 7, C is negative 1, right? So we put these in, so negative B, negative 7, plus or minus, square root B squared, 7 squared, minus 4 times A, which is 2, times C, which is negative 1, all over 2 times A, which is 2. And so I'm going to simplify the inside here on my calculator, so I'll just go 7 squared. Make sure you do put this in parentheses. It's really crucial to do that, especially if it's, well, when it's negative, especially. Minus 4 times 2 times negative 1, so 57. And then this is 4 in the denominator. You would want to do any reducing if you can. I think maybe 57 is divisible by 19, but that's not a perfect square anyway. Yeah, so there's no perfect squares that go into 57, so that's it. These are actually 2 answers. Usually, remember, you do get 2 answers with quadratics, not always, but so negative 7 plus square root of 57 over 4 is one answer, negative 7 minus square root of 57 over 4 is the other answer. Okay, so that's a little review of how to solve quadratics.